So I've been developing my game recently, and I've had this little cool mechanic with the planet that has a gravitational pull. So I've decided why not make a tutorial on how to make it. But before we get into coding in Unity, let's first of all take a look at how this works from the logic side of things, and then we can move on to the code. To start off, we're gonna need a couple of things. The first thing we need is our planet or our black hole or whatever object you want to use to be the source of the gravitational pull for the player. This right here is represented by our white hexagon, which in my case, in my game, I'll just call a black hole, even though it's not really black, but who cares. Another thing we have is we have a player character, which is represented by the green glowing square, and we have a couple of other things. This little white dotted line on the edges is representing the gravitational influence range. Now, in real life, a object's gravitational pull is infinite, so if you can be on the other side of the universe, and the object will still have a gravitational influence on you, even though it'll be basically zero, it's still technically there. But in our game, we don't want it to be outside of a certain range just because we can do a lot more cool stuff with it, so we have just simply put a gravitational influence range for our objects, just for fun. Another thing we have right here is the gravitational pull vector, which is normalized. Now we're going to see how we calculate the gravitational pull vector later on, but it's really important we normalize it so we can apply our own custom scalars so we can define how strong a gravitational pull is with much more consistency. So let's move on to variables and other stuff we need. In our variables list, we have a couple of items. So the first thing we have a reference to the player transform. We have a reference to the player's rigid body so we can apply physics to it. We have an influence range variable, which I have put public so I can edit it from the inspector. We have two variables that are calculated each frame, and that would be distance to player and pull force vector. And finally, we have a custom intensity, which is just a utility variable so we can play around with the feel of the game, so we see what works best in our case. So how do we calculate this pull force that's driving our player towards the black hole in my case? So we need a vector that's pointing from our player towards the center of the black holes. How do we do that? We simply go black hole.position, and from that we subtract the player.position. Now, if you do not know vector math, I highly suggest checking out the link in the description, because knowing vector math and developing for Unity is really useful and solves a lot of problems and headaches and just makes development so much easier, so I highly encourage it. After we have that vector, we want to normalize it so we can play with it a little bit more and we can customize it much easier. The next thing we do is we divide it by the distance to player. So we want it to be a less of a pull the further away the player is. Now in real life, the actual equation is divided by the distance to player squared, but I found that it's just not that much fun in my game, so that's how I did it in my game, by dividing it simply with the linear scalar. And finally, we just multiply it by the intensity, which just makes it much more fun. We can maybe even modify intensity during runtime. We can let the player choose the intensity. We can, create some power-ups. Basically, it just creates a lot more utility which you can use in your game to create more and more fun. So now that this is out of the way, let's go to Unity, see how it's set up, and after that we're going to go into Visual Studio Code, see how the actual code works. Back in Unity, we have our black hole object with a bunch of stuff attached to it and a bunch of child objects. Now, I want to point out that, for example, this rotator script and the particle system have nothing to do with the actual mechanic. They're just here for visual fidelity. So I won't be commenting on how I made those in this video. If you would like that, leave a comment and I just might do it. But back to the mechanic in question. So we have our little black hole script attached to our black hole object. We have a player transform reference right over here. As you can see, it points to our player. We have the influence range, which I have put at 4, and the intensity, which I put at 6. Now, of course, in your case, you'll have to play with these numbers a bit, see what works for you. And, it depends on the player mass and whatnot. And we have the distance to player, which doesn't need to be a public variable or a serialized variable, but I've just made it so in my case, it was just easier to develop for it, see how it behaves, see how far the player is, how soon I wanted the gravity pull to start influencing the player and whatnot. So it's just for debug purposes. Now that we have seen everything there is in Unity, we can go to Visual Studio Code and see how the code works. In Visual Studio Code, we have a public transform player, a rigid body 2D player body. Now in your case it might be just a regular rigid body, but I'm making a 2D game, so I'm using rigid body 2D. We have a public float influence range, we have a public float intensity, we have a public float distance to player, and as I said, this doesn't have to be public, I just like making it so, and we have a pull force vector 2. Now at the start of the game, we first just get the component rigid body 2D from the player. You could of course manually assign it by making this public and then dragging it in the inspector. I just like to do it like this in my case. And here's the whole brains of this. So each update, each frame, we calculate the distance to player by simply going vector2.distance, we give it the player position and the transform.position. Now why transform.position? Because the script is attached to the black hole object, so transform.position is the position of our black hole. Now if the distance to player is less or equal to the influence range, we start the calculation. So pull force is equal to transform.position, which is the position of the black hole, minus player.position.normalized. Then we divided it by the distance to player, so we scale it down depending on how far away the player is from the black hole. And finally we multiply it by intensity. Now once we have this pull force vector, we go player body, which is a reference to the rigid body 2D component of our player, and we go add force. Now of course we need a vector2 force and a force mode 2D. The vector2 force is the vector2 we have just calculated, called pull force, and force mode 2D is just force mode 2D dot force, which as it says, add a force to rigid body 2D using its mass. So in my case I have just a simple default value of mass. Of course you can manipulate it, increase it, decrease it, play with the intensity, see what works best for you. So that's it for this video. If you have any questions, if you have any bugs that you got stuck with, oh my god, that was so close. That was so close. But yeah, if you have any questions, if you had any criticism, please feel free to leave a comment below. I'll try to answer as many as I can. I hope you have a nice day, and I would of course appreciate a like and subscribe. And finally, I will see you all in the next video, hopefully. Goodbye.